Hi guys, I'd like to welcome each and every one of us to my channel of Honest Sciences and Mathematics TV channel. In this particular discussion, I'm going to look at different types of measures of dispersion. And of course, this is going to complement on our previous video that we had done on the concept of measure of dispersion, or the concept of dispersion and different types of dispersion that we had discussed in a summary form. Now, from our last discussion, basically I had mentioned the concept of measures of dispersion, which as well I said can be referred to as measures of variation or variations. And in this case, I had given two specific sets of measures of dispersion, which we had mentioned for absolute, and of course the second one that we had referred to as the relative measures of dispersion. And in this case, I had mentioned that basically measures of dispersion which have been given in their original units are going to be given the term absolute, while the ratio, basically the relative measures are going to be the ratio of the measures of absolute, or the ratio of absolute measures with a specific measure of central tendency. And in this case, of course, it can be given in terms of a particular percentage, as we're going to see later in a subsequent discussion. Now, on the board, I've given a specific range of two particular distributions for x and y. And this is going to extend from this particular range of values up to the last one, which I've given in terms of this lower part, due to space, of course. So this is going to be a set of distribution given in this particular order, whereby, as we're going to see, for the first values, they're going to be given with respect to x and y in that particular case. Now, from our last discussion, I had basically mentioned a few terms which we were going to consider in trying to describe the frequency distribution. And I mentioned the concept of what we refer to as a range. And I said that the range is the difference between the largest and the smallest value of a particular distribution. And in this case, I have given specific initials for range to represent R to represent range. And then I said that we're going to develop an algebraic representation of this specific relationship by having R is equivalent to L minus S for the largest and the smallest value of a particular distribution. Now, from this particular case, then therefore from the example that I've given on the board, we can be able to compute our range for the distribution of x and y respectively. So if we try to consider the concept of range, then therefore for x, we're going to see that basically we're going to find the range for x, perhaps if I may give it in this specific case, for the largest value in x, of course, minus the smallest value in x given as such. So we're going to identify the largest value, and in this case, this is going to be given as 45. So therefore, the largest value is going to be represented by 45, and the smallest value, perhaps it is going to be given in terms of 32. And the difference between these two is going to be given as 13, given as such. So for the second distribution, we can also compute the concept of range by having the smallest, of course, value for y and the largest value for y, and finding that difference as such. And of course, this is going to also constitute the largest value of 45 minus also 32 for the smallest value. And basically, as we're going to see this, the range, the numerical value for the range of these two specific distributions is going to be the same. But as we can visualize and see, there's going to be a specific trend, especially starting from this specific point, that's going to show a particular variation between these two spread of data. And therefore, if we were to consider this specific characteristic of this specific, of course, variation, or in the amount of variation of this specific data that we're going to refer to as dispersion, is going to be quite significant for the two specific sets of data, in as much as they may consist of the same range. So therefore, this is going to pose a challenge for us in trying to use this concept of range as a measure of a variation or dispersion, and therefore we're going to mention that one as we go by in our specific discussions. And in this case, from this specific data, then therefore we can see one of the characteristics or the shortcomings of range. And in this case, then therefore we're going to reserve that one in our next discussion. In this case, I'm going to look at the concept of range and how we can represent this particular concept of range in terms of these measures of dispersion. And dimension basically that's of course range constitute the difference between the largest and the smallest value of a particular distribution. And of course, as I've given from the algebraic representation, that's going to be the formula which is going to be used for measuring range. Now, one of the aspects of this range is that for the extreme scores of data, for example, for the one that we have given, of course, and or the one that we may come across, this aspect of range is going to be affected by extreme ranges of data. Therefore, that's going to be one of the shortcomings of this particular aspect of course, measures, and therefore that's going to pose a picture of course, an irreliability of this specific way of trying to describe the concept of variation as I mentioned. Now, in this specific case, we are going to see that from that particular challenge, range is not going to be one of the reliable measures of course, this concept of dispersion. But we can describe range for a specific set of data for the grouped and ungrouped, which are mentioned in my previous discussions on various aspects of the measures of central tendency. And that is going to assist us compute range in case we come across a grouped set of data in that particular case. Now, this is going to be considering the concept of a continuous frequency distribution. And of course, range is going to be given in terms of this specific initials. So as I had given for the general illustration, we're going to use this specific initials for representing or computing range, whereby this is going to be UCLK. And I'm going to elaborate on that specific formula, and then we're going to have LCLK given as such, and I'm going to elaborate on that as well. Now, in this case, this is going to represent the upper limit of the last class, and of course, this is going to represent the lower limit of the first class given in that specific case. Now, in this case, we had said that if we're going to arrange a data, it's going to be given in terms of ascending, or for us in trying to describe the various ranges of classes in group data, we're going to arrange that one in terms of ascending order. And therefore, for us to consider the last class and the first class, these are going to give us the limits of those specific upper and lower values of a specific distribution. So therefore, for us to give a range in terms of UCL sub k minus LCL sub k, this is going to represent the upper class limit of the last class of that specific data minus the lower class limit of the first class of that specific data in that particular order. Now, sometimes we're going to use a specific formula or a general one, specific formula or a general one representing range, and this is going to be given in terms of LK x k minus x L given as such, or x1 given as such, and this is going to represent the class mark of the last class, and this is going to represent the class mark of the first class in that specific case. Now, I'd say that basically if we have a specific class given in terms of perhaps 60 to 70, we can compute the class mark by finding the average between these two specific limits for the upper and lower class limits given as such, and this is going to give us the value of 65. So this 65 is going to constitute what we refer to as the class mark, and that's one of the ways in which we can consider, apart from this general case, in trying to find what we refer to as the range. Now, in our next discussion, we're going to use specific examples in trying to compute range from a grouped and ungrouped data, or rather in this case, grouped data, which are specifically given for these two specific formula, which are going to consider the concept of a class as I've mentioned in this particular discussion. So check our description boxes for other videos which we are going to do, and kindly subscribe to our channel and follow us in the comment section so that we can be having a healthy discussion on various topics in this broader topic of statistics. So that is it for now, guys. Bye, God bless you. Catch us in our next video.